my fellow mathematicians. Welcome to the study of complex maths. Here you are going to check whether this function, which is a parabolic of cos of z, satisfies the Cauchy Reimann equation. Now, to do that, you require a number of prerequisite knowledge. One of them is how to expand the parabolic of trigonometric function. So we are going to make use of this general idea that if we are given a parabolic of a plus b, then the result will be a parabolic of a parabolic cos of a multiplied by a parabolic cos of b plus a parabolic sine of a multiplied by a parabolic sine of b. So we are going to make use of that identity. Number two, we are also going to make use of this relationship that when you have a parabolic of a is the same of a parabolic cos of a is the same as cos of IA. We are going to make use of that. Another thing we are going to make use of here in this presentation is that when you are given a parabolic sine of IA is the same as I sine of A. So we are going to make use of those three facts in this working. So f of z, which is equal to a parabolic cos of z, can be written as cos of iz by use of this fact here. Then we make use of this, and remember z is equal to x plus iy. Z is equal to x plus iy. So, which means that cos of iz, I can be outside. Instead of z, we write x plus iy, which becomes cos of bracket ix minus y, using the fact that I squared is equal to -1 here. This is I multiplied by I will give you I squared. So f of z is equal to cos of -y plus I z. Then we make use of this identity. Now we expand our identity to obtain the following. So this will give us cos of y multiplied by cos of ix sine of y sine of ix. Now I have made use of this substitution here to simplify this case. Remember, cos is an even function. So cos of -a is the same as cos of a. So I have made use of this fact here, and I have also made use of this fact that the one we have up there. Now at this level now, we write this function in the form of u, whereby u is a function of x and y, which is equal to cos of y cos of ix, there is I there. Then v, which is a function of x and y, will be equal to sine of y sine of ix. Now, making use of coming back here again, instead of cos of ix, we are going to use a parabolic. So our function u, which is a function of x and y, can be written as cos of y multiplied by cos of a parabolic of x. Function x of yv can be written as sine of y multiplied. Then from there, the next thing we get partial partial of u with respect to x. This case here will give us cos of y multiplied by hyperbolic sine of x. Then we get partial of u with respect to y, which will give us partial of v with respect to y, which will give us cos of y multiplied by hyperbolic sine of x. Then we get partial of v with respect to x, which will give us, this one is going to give us, when we differentiate this, it will give you sine of y multiplied by hyperbolic cos of x. The next thing now, it is now to make use of Cauchy Reimann equation. We compare partial of u with respect to x. We see whether it is equal to partial of v with respect to y. Our partial of u with respect to x is cos of y multiplied by hyperbolic sine of x. Our partial of v with respect to y is equal to cos of y multiplied by hyperbolic sine of x. So CR, first equation number 1 is satisfied. Then we check for the second equation, which is partial of u with respect to y should give us negative partial of v with respect to x. With respect to y is equal to negative sine of y, hyperbolic of cos of x, and our partial of v with respect to this is equal to sine of y multiplied by cos of hyperbolic cos of x. Now, even the second equation is satisfied. So, CR equations are satisfied. Satisfied, meaning that our function, which was f of z, which is equal to cos of hyperbolic, is analytic on the complex plane, because we have obtained that these equations, the CR equation or Cauchy Reimann equations, are satisfied by this given function. So to check whether a function is analytic, or what you need to do, it is to use this fact that z is equal to x plus iy. Also make use of these equations, the partial derivative, and also know that u is equal to u, which is a function of x and y, and v is equal to v, which is equal to a function of x and y. Then you get the partial derivative. In our case, we have made use of this fact that cos of y is the same as hyperbolic of cos of x, and I sine of y is equal to hyperbolic of sine of iy. So that is what we have made use of, together with the sum of trigonometric function, whereby this one gives you the following: cos of b minus plus or minus sine of a sine of b. So that is what we have made use of here. So thanks so much for taking your time to study with me on analytic function, on how to prove that your function is an analytic using what is referred to as CR equation or Cauchy Reimann equation. Kindly remember to tune on to my YouTube channel so that you may continue learning together. Let me hear also any other approach which you could be having on how to check whether Cauchy Reimann equations are satisfied, so that we may learn together. Bye bye, see you in the next presentation.